This one's trickier. So I don't have a fraction. I do have a fraction in the exponent. So I'm going to suggest you go inside first. So what I want to do is I want to think about the graph of 1 over x, and you know that this is the graph of y equal 1 over x. As I'm going to 0 from the positive side, where am I going? I'm going up to positive infinity. So now I'm going to be thinking, you don't ever write the infinity thing, so you're thinking I'm going to go to e to the infinity. Oh, wait a second, that's just infinity. Again, you just think this. So this one's really similar. So I'm going to go to the inside first. So I'm thinking I want to take the limit as x goes to 0 from the negative side of 1 over x. Same graph, going to down here. So that will give me a negative infinity. So what that means is I have e, and I'm thinking this, not writing it, e to the negative infinity, which I know is e to 1 over e to the infinity, that's 0. Okay, let's look at this one. So tangents, you got to know your graphs. So your graph of tangent of x has an asymptote right here at pi over 2 and negative pi over 2. So this says go towards pi over 2 from the negative side. Oh, that's going up there to positive infinity. No L'Hopital's, just limits, right? Let's look at this one. So if I put an infinity, you know that 1 over infinity is 0. Wait a second. What's ln of 0? You can't do ln of 0. That's a negative infinity. You could say infinity, or you could say dne, or you could say negative infinity. Any one of those are fine answers. Let's look at this one. If I put in infinity, I get infinity over infinity. So let's do L'Hopital. So I'll get 2 ln of x times 1 over x, doing chain rule, right? All over 1. Okay, I'm going to rewrite this as the fraction that it is. So I'll have 2 ln of x over x. Now what happens? If I put in infinity, I get infinity over infinity. All right, there we go. So that gives me 2 times 1 over x over a 1. Then I get 0. 4 to the x. Do we know the derivative of 4 to the x? We do. The derivative of a to the x is a to the x times ln of a. All these things you just need to know. So if I put in 0, I get 1 minus 1, which is 0 over 0. So let's do the derivative. 4 to the x times ln of 4 minus 3 to the x times ln of 3 all over, oh, just 1. I didn't really need to write that, did I? So plug in x equals 0. I end up getting ln of 4 minus ln of 3. And I don't want you to be confused. Sometimes, that's a fine answer, and you can leave it like that. Sometimes I like to simplify my answers, and I just write this. And it's just a matter of how much I need to type to make the answer sheet, because I make all the answer sheets, right? Let's look at this one. So if I plug in 0, I get cosine of 0. Hey, wait a minute. What's cosine of 0? That's 1. And what's e to the 0? That's 1. Oh, not a trick problem. Just you always have to check if you can use your L'Hopital tool. It's just a tool that only can be used if it's 0 over 0 or infinity over infinity. This one does give me 0 over 0. So I'm going to take the derivative, 1 over, and you know the derivative of arctangent. Let me remind you, derivative of arctangent of, I'll just put the u in there, 1 over 1 plus u squared times du over dx. Okay, so I'm going to have 1 over 1 plus 5x squared times the derivative of 5. So then I'm just going to multiply by the reciprocal. So I get 1 plus 25x squared over a 5. Now plug in x equals 0. I get 1/5. And let's look at this last one here. So if I plug in x equals 0, I get 0 minus 0 in the numerator, 0 minus 0 in the denominator. All right, so 1 minus cosine of x all over 1 minus secant squared of x. Cosine of 0 is 1. Secant squared of 0 is 1. I end up getting 0 over 0. So I get to do L'Hopital again. So take the derivative of negative cosine, that gives me a positive sine. Take the derivative here, make sure you're using chain rule. So -2 secant of x to the 1 power times the derivative of secant, which is secant x tangent x. Wow. As soon as I see all of these trig functions, take the time to rewrite them in terms of sines and cosines. So limit as x goes to 0. So what I mean is, this is secant squared, right? So I get a -2 over a cosine squared, and then tangent, you know, is sine of x over a cosine of x. Okay, so let's see what happens. Limit as x goes to 0. So I get this multiplied, right? That's the numerator. And then I'm going to multiply by the reciprocal of this. Whoa. So what do I end up getting? I end up getting a cosine cubed x over a sine x. Oh, well, that's convenient. Those sine x's cancel. Oops, I dropped my -2, right? So it stays down here. So then I get, let's write it here, limit as x goes to 0, cosine cubed x over a -2. So now when I plug in x equals 0, cosine of 0 is 1. So I get a -1/2.